Brought to you by DCP Player. Preview any DCP ad or trailer on any PC. For more information, go to dcpplayer.net. Brought to you by DCP Encoder, a cost-effective way for a cinema owner or content producer to go to the DCP file format. For more information, contact dcpencoder.net.
Good afternoon, everybody. As Bill was saying, I'm going to talk about the screen applications for 3D, and in particular about getting acceptable light levels on 3D systems. There are many technologies available that Bill has just gone through. The recognized accepted light level for 3D is 5 foot lambdas, but recognizing that it is difficult to get adequate light levels, and that compares with 14 foot lambdas for the simply standard for 2D digital. The thing about 3D, and all systems suffer from this to varying degrees, is they suffer from a huge amount of light loss as a result of going through the eyewear and the other filters they have to put in the system. And they all have, as Bill has said, different eyewear requirements. In terms of overcoming this light loss, there are two things you really have to think about: the projector and the lamp, and the screen. And I would argue that whatever system you use, and I'll talk about this in a minute, you need a gain screen, a screen which actually has got some gain. So you need to consider the lamp and the screen gain together. What is a gain screen? A gain screen is a screen with a special reflective coating. The screen itself cannot create light, it can really direct the light back to the audience. And a gain screen achieves a higher degree of brightness, but it actually reflects more light back to the audience than a conventional matte white screen, which scatters lights in all directions, the floor, the ceiling, whatever. Gains are available up to 2.4, and that compares with a matte white, which has got a nominal gain of around 1. And gain is measured by various international standards, so they can actually determine exactly what the gain is. If we look at digital 3D systems, and excuse me for not including film ones in this, but here we have the technologies that Bill was talking about, and Sony is a variant of, obviously, of the Real D system. The Real D systems, there are two of them, both using polarized light, have very different light efficiencies. The normal Real D system has about 15% light efficiency compared with 2D. The XL system is almost twice as good. Dolby has a system, a measurement of around 12% actual light efficiency, so it loses 88% of the light available. Expand is around 18%. And master image is around 15-16% in terms of their efficiency, so they're losing a tremendous amount of light, given that 100% will be the 2D thing. I've also listed there the screen type. The Real D systems and the master image systems and Sony's Real D system all use silver screens, which they have to do because they are all using polarized light, and polarized light the polarization needs to be maintained with the polarized light, and silver screens will do it, and white screens will not. So any system using polarized light, whether it be linear or circular, requires a silver screen, and that applies to the film systems too, which Bill mentioned just now. Both of those use polarized light. The other systems from Dolby and Expand use white screens, and whereas you can use existing screens in theaters if they're white, if they're not high gain, the light levels are going to be pretty low. And there are white screens available up to gains of 2.2, which can help enormously with getting the right light level on the screen with these white screen 3D systems. I have actually put up in the last column there what happens when you go back to 2D mode. Because clearly, if you've got a very inefficient system in 3D, and you've got a very high gain screen, a bright lamp, you're going to have a very bright system in 2D. And this is the numbers at the end are based on the assumption that 3D achieves 5-foot Lamberts, then for each of the systems you get, because of the different light efficiencies, you get very different situation in 2D. So the more efficient the system, then the lower the 2D foot Lamberts will be, if the 3D foot Lamberts is 5. So you can see that with a real D XL system, for example, which is quite light efficient, the foot Lamberts in 2D are 19, which is not so far from the standard of 14. Whereas if you've got some of the less efficient systems, you're really going to have to do something about the brightness levels. It'll be so bright in 2D that you're going to have to change the lamp or do something else. So in summary then, and this is a short presentation, achieving acceptable light levels, really, you have to look at the projector, the lamp, and the screen together. So it's not just the width of the screen that matters, it's the gain level that matters. Now with silver, you have no choice. The gain is fixed at 2.4 or thereabouts from the various suppliers of silver screens. With white screens, you've definitely got a choice, up to potentially 2.2 gain. We have developed a thing called a digital screen selector, which is available on our website, which will enable you to actually see how the screen width and the gain go. And I'll give you a few quick examples, which are just snaps on the website here. This is a screen selector thing that you get from our website. You basically put into it, whether you're doing 3D or 2D, it will handle 2D as well. You put in the technology type, and you put in the projector type, and you put in the screen width, and you put in the foot Lamberts, and it'll actually tell you the lamp you have to use for that particular screen width. In this case, it's a 3.5. It'll also work with all other technologies. Here's an example where you've got Dolby with various screen gain options. And again, these are different screen gains for a given width. You can see they have different lamps selected. You can go onto our website, you can do this, you can play with it. It's on artiscreens.com. Thank you very much indeed.
Question.
Any questions? Yeah.
Why is 5-foot Lamberts considered acceptable when it's not? When it's 14?
Well, I'm only quoting what the studios have considered to be acceptable in terms of the way they calibrate the films that are coming out. I think most people would agree that more than 5-foot Lamberts is highly desirable, but because of the losses in the system, it's very difficult to achieve it. But it's a studio figure, it's not something I dreamed of.
It's acceptable in the sense that this is what we can do?
Acceptable in what we can do, and the studios recognize that. I think all the studios would actually want more, but in terms of practically getting 5-foot Lamberts, it's probably the best thing we can expect to get. Any other questions? Yeah,
what about the prospects of the silver screens? Different gains.
Well, I mean, clearly the higher gain, there is some risk of hot spotting. I think 2.4 is about the point at which you can go to without getting hot spotting. Digital obviously helps, but it's a light distribution from digital film. There are two factors with the silver screens. There's a signal to noise ratio, which is the amount of the crosstalk, and then there's the gain level. There is a sort of correlation with gain and signal to noise. In other words, the signal goes down to gain, so you tend to have a risk of getting more crosstalk as the gain comes down. It's one thing that we're trying to work on is actually get the gain a bit lower, but actually get the signal to noise ratio up, so you actually can have what ideally you want. Then you have to have an even brighter projector, of course, to deliver the light. Any other questions?